the annual daycare cost per child is normally distributed with a mean of $6,000 and a standard deviation of $1,400. What percent of daycare costs are more than $5,600 annually? So with a situation with normal distribution, our goal is to be able to standardize this picture. So a normal distribution problem is set up with a picture like this where we have the mean in the middle. So our mean is $6,000. Our mean is symbolized in statistics with mu or x bar if it's a sample mean. This is a population mean. So we have $6,000 for the mean, and then the standard deviation is 1,400. That's symbolized with sigma. And we're wanting to find out a percent of daycare costs that are more than $5,600 annually. Well, $5,600 is below the mean, and we're trying to figure out the percent of area that is all the way to the right of $5,600. Right now, we have a table of values that we look up our percentages, and $5,600 is not located on that table. So we have to standardize our value first. We use the z-score formula to standardize. It's x minus mu, or x bar, divided by sigma, standard deviation. So we're searching for the percent that is more than 5,600, and so that's our x that we're trying to convert. 5,600 minus the mean, 6,000, divided by the standard deviation, 1,400. So z equals, so first we'll subtract on top, 5,600 minus 6,000, and we get negative 400. Divide that by 1,400, and we have negative 0.285714, and this decimal just doesn't terminate. When we look up values in our table, we need to round to the nearest hundredth for a z. So we look at the third decimal, and if it's 5 or greater, we're going to round up. So z is negative 0.2, and the 8's going to go up to a 9. So that means that on my normal distribution curve, I've now standardized it so that the mean is 0, and this is just a number line. And negative numbers go to the left of 0, so negative 0.29 is in the same position as the 5,600 was. So I'm going to draw up to my curve, and I'm shading all the way to the right, and now I have a z that I can look up in my table of values that's provided. So I want to look up negative 0.29. So I'm going to go to my z table now to find negative 0.29. So looking in this first column here, I'm looking at negative 0.29. So make sure you're not looking at the 2 point there. You're looking at 0.2, and that's down here. And then I'm looking in the hundredth position for the 9. And so joining this together is going to land me on my area, 0.3859. So this is always area to the left of your z. So 0.3859, I'm going to go back to my picture and put that in my picture. So 0.3859 is the percent of area that's to the left of your z, and that's not landing in the correct direction. We want to go more than or to the right. Well, remember that under a curve, we have 100% area fits under the entire curve. As a decimal, that's equivalent to 1. So if we want to go to the other side, we just have to subtract the percent that we're given from 1. So 1 minus 0.3859 is 0.6141. Or 61.41% area is going to be to the right of negative 0.29. And this one says to round to 2 decimals, and it's also asking for the percent. So that's why they want us to round it. Probably notice here that 0.6141 or 61.41% is not what you see here for this potential solution that's posted. So I want to show you, this is what the instructor sees. Depending on the technology that you are using to solve, they give you a margin of error for possible precise results. And so if I look at the My Math Lab potential solutions here, it gives me 0.6141 or 61.41 plus or minus 800ths, and then we have 61.25 plus or minus 800ths. So that would be counted as a correct solution.